Homework 27, question 9. In this question, I've drawn the diagram for both parts A and B already, but I'm just focusing on the trajectory of stone A in part A only. We are told that this stone is thrown vertically upwards with speed 20 meters per second from point A, h meters above the ground, and the ball moves freely under gravity until it hits the ground 5 seconds later. So, I've drawn a curve because that's easier to illustrate. In reality, the stone is going straight up and straight down, but my lines would overlap each other. So I've just added on the second dimension to make it a little bit clearer. I need to choose a direction that is positive, and I chose to make down positive. This has the effect of making my initial velocity negative and my acceleration positive. S in a Hwk question represents the displacement, not the distance. So while my stone is actually travelling up and then down, it is only being displaced by h meters. My Hwk question is s equals ut plus half at squared. If I substitute in all the information that I've got, I get h is equal to minus 20 times 5 plus half times 9.8 times 5 squared. And if I put that into a calculator, I get 22.5 meters. In part B, we've got a second ball being thrown vertically downwards with speed w meters per second from A and moving freely under gravity until it hits the ground. Because it's being thrown downwards, I know that my value of w needs to be a positive number. I'm told this time that the first ball hits the ground with speed v, and the second ball hits the ground with speed 3/4 v, and I need to find w, the initial speed. I've still got the same information that I had before, first ball A, with the added information now that s is equal to 22.5 meters. I have to find v. I've got 4 equations I could use to do this. This is my preferred one. So v is equal to minus 20 plus 5 times 9.8, which means that v is equal to 29 meters per second. I can now use this information in the information that I've got about stone B. I know the height because it's the same. W is what I'm trying to find. I know its final velocity. I know its acceleration, but I don't know how long it takes to do the journey. The equation that I need to use this time then is v squared equals u squared plus 2as. Now, if I've got 3/4 of 29 squared, that is 9/16 of 29 squared. And that is equal to w squared plus 2 times 22.5 times 9.8. Simplifying this, I get w squared equal to 513 over 16, which means that w is equal to the square root of that, which is 5.66 meters per second, to 3 significant figures.